Hi everyone, this is a new bench grinder that I just purchased, actually for myself. The shop here I'm at doesn't have one of these traditional bench grinders. It had one of these machines, which I'm not too familiar with, but from the videos I've seen, look like they have potential. But I've always wanted my own more traditional bench grinder, so I just got this one recently. And yeah, so today, right now, I'm just going to check the wheels and give it a good ring test first to make sure that it's safe. So I'm going to take off the guard. Alright, now that the guards are off, I'm going to take off the flange nut here. It's important to know that on the right hand side of the machine, this is a right hand thread, righty tighty, lefty loosey, like we're all used to. But on the left hand side, the nut is reverse. It's a left hand thread. So lefty tighty, righty loosey. And as far as I know, all bench grinders are opposite threads on each side of the machine. So that's really important to know. Get the right size wrench and we'll start to take that off. Alright, so the wheels are off right now, and if we zoom in, alright, if we look at the blotter here, that's the paper with all the markings on it, the first letter, the W, is the prefix, and that's made by the manufacturer. Sometimes it's used to indicate the exact type of abrasive. It doesn't always mean much to us from a standardized chart. This prefix is very brand specific and often optional. I don't usually pay too much attention to this. Alright, the second letter here, the A, represents the abrasive type. A means aluminum oxide, and the other one would be C for silicon carbide. Aluminum oxide is good for high tensile strength materials like carbon steels, alloy steels, high-speed steels, where the silicon carbide is good for grinding high-density materials, but with a low tensile strength, such as cemented carbides, apparently cast irons, non-ferrous and non-metallic materials. Silicon carbide wheels are often green in color. I have only used silicon carbide wheels just a little bit in my career when I was a metal worker, and I've only used them for carbide related tooling. I've never actually tried cast iron or non-ferrous materials personally. The 120 here represents the grain size. According to my chart, a grain size of 10 to 24 is considered coarse, 30 to 60 is considered medium, 70 to 180 is considered fine, and 220 to 600 is considered very fine. Okay, the N represents the grade, and this refers to the bond, not the grain or the grit. So a stronger bond is considered a hard grade. These wheels, you might have seen, they kind of look a little bit glazed, and they often need to be redressed. Hard grade wheels are used for grinding softer materials, where a soft grade wheel is used for grinding harder materials. With a soft grade, the grains are often removed and new sharp grains are exposed. Sometimes they refer to that as friability. I have to say, after some first tries here with this new grinding wheel, I like this grade N for grinding tools. I do notice a little more grinding dust, so I think there's more friability. But I also noticed that the tools so far don't seem to heat up as quickly as a more general purpose grinding wheel. So far this grade N, I like it for tools. Alright, the 5 represents the grinding wheel structure, and that's often the spaces or the pores between the grains. For soft materials, you want an open structure that helps with like chip flow, but hard materials, they resist cutting, so it's nice to have more grit and smaller spaces for harder materials. The last letter here, V, represents a type of bond. This is a vitrified bond. Most grinding wheels are vitrified bonds, but there's other ones out there too, like resinoid, silicate, rubber, and shellac bonds, all for different purposes. But by far the most common is the vitrified. And likely so, here's our coarse wheel. If we zoom in on this one, we'll have similar markings, but instead of 120, we'll have 60. So the grit here is a 60 grit, the grain size. And that is, according to my chart, falls in the upper side of the medium range. So, okay, this is a really important part for checking a wheel. It's the ring test. You want to use something non-metallic, like the end of a screwdriver. A wooden mallet can also work as well. And you want to give it a light tap on several places around the wheel, and you should hear a nice clear, uninterrupted sound. That's good. And that's good crystal. Okay, so the wheels have passed the ring test. There's no apparent chips or cracks on the wheels, so the wheels are good to reinstall. Before we reinstall, we should make sure that everything is nice and clean in here. The shaft is smooth, no nicks or burrs. Right, we want all the pieces to come together properly, nicely. Right. This thing's is not a high-speed grinder. This one spins at 1,700. But still, it's important. That's still pretty darn fast. But some of these machines will spin at 3,000 or more. So we put the first one on. Make sure it's nice and feel for anything. Okay, this paper here is the blotter. It's really important to have one on both sides. The blotter acts as a cushion, and it has to be between when everything presses. So never peel off the blotter. It's not only is it for a label, but it's for a cushion as well. Sometimes, especially with the newer bench grinders, the two flanges are there's not much grip with that and the blotter. So sometimes you need to give it a little bit of a quick, tug to get it to tighten on. The nice thing is, because it's right hand and left hand threads, in theory these should be self-tightening when the machine's turned on. Alright, so now we're going to set the tool rest in place, and we want about a 1/16 gap. And we also want a 1/16 gap here for the spark arrestor. So this moves up and down, and this moves in and out. While I do this, I'll keep the machine unplugged. So while the machine's unplugged, if I give it a spin, it doesn't touch. It doesn't touch up there. That's good. Always use the proper size socket. My goodness, I've seen so many of these hexagon heads rounded off. Always use the proper size. This makes life so much better. And feel free to write down the size too, so other people get the hint, you know? Adjust the guards. Okay, so when do you change a grinding wheel? Well, if it's chipped or cracked, obviously you got to change the grinding wheel, and if the grinding wheel is bad, destroy it before, so no one else can use it by accident. But when a grinding wheel, I find, is about 2/3 used up, it's a lot smaller and it doesn't seem to perform the same. Also, sometimes too, the tool rest can't go in anymore, and now you're getting a gap, and that's also kind of an indicator that the grinding wheel is near the end of its life. But I find the performance changes a bit too, because regardless of the size of the wheel, this one spins at 1700 RPM. So how a grinding wheel works is in surface feet per minute. That's the distance it would travel in a minute. So if you do one rotation of this pen, it travels that far. But if you do one rotation of a larger wheel, well, it traveled a lot farther than the pen. So as the wheel gets smaller, its surface feet per minute decreases, and that affects the performance.